Volcanoes, the beating hearts of planets. Volcanoes are the universe's most spectacular release valves, places where the inner fire and hidden chemistry of worlds burst forth onto their surfaces. They are both destroyers and creators, capable of turning landscapes into ash in a single night, or building entire islands that last for millennia. In studying volcanoes, we aren't just watching rocks melt, we're peering into the engines that keep planets alive. The sleeping giants of the Moon and Mars. Our own Moon, quiet and gray today, was once a world of fire. The vast dark seas we see with the naked eye, the Maria, are not seas at all, but immense lava plains. Billions of years ago, molten rocks surged from below, filling giant impact craters and leaving scars so huge they can still be seen from Earth. On Mars, volcanism went further. The red planet is home to Olympus Mons, the tallest volcano in the solar system and the largest mountain known anywhere in the universe. It towers 25 kilometers into the sky, about 3 times higher than Mount Everest, and its base spreads across an area roughly equal to France. To stand at its foot would be like looking up at a mountain so vast it vanishes into the thin Martian atmosphere. Though extinct today, Olympus Mons tells us that Mars was once geologically restless, with flows of lava that could stretch for hundreds of kilometers. Io, a world of eternal fire. But if the Moon and Mars show us volcanoes of the past, Jupiter's moon Io is a world locked in permanent eruption. Tugged by Jupiter's massive gravity and the pull of other nearby moons, Io's crust is constantly flexed like a stress ball. The friction generates staggering heat, melting rock beneath its surface. The result? Over 400 active volcanoes, the most of any world we know. Lava fountains shoot 500 kilometers into space. Rivers of molten sulfur paint the land in yellows, reds, and blacks. From orbit, it looks like a planet cursed, a true hellscape that earns its title as the most volcanically active body in the solar system. To visit Io would be to step into a nightmare, but also into one of the most spectacular displays of planetary energy in existence. The icy volcanoes of the outer solar system. Not all volcanoes spew fire. Beyond the asteroid belt, in the frozen kingdoms of Saturn, Neptune, and Uranus, volcanoes erupt with water, ammonia, and ice. These cryovolcanoes blur the line between geology and biology. Take Enceladus, Saturn's gleaming moon. Though only about 500 kilometers across, it hides a liquid ocean beneath its icy crust. Through cracks near its south pole, jets of water vapor and ice blast into space, soaring 700 kilometers high, so far that the ejected material contributes to Saturn's E-ring. When NASA's Cassini spacecraft flew through these plumes, it detected salts, organic molecules, and complex chemistry, the same ingredients that, on Earth, form the foundation for life. Europa, one of Jupiter's moons, is another icy world where cryovolcanoes may lurk. Its cracked surface hints at powerful forces beneath, and scientists suspect its subsurface ocean contains more water than all of Earth's oceans combined. If volcanoes there deliver heat and minerals, Europa could be one of the most promising habitats for life in the solar system. Cryovolcanoes remind us of something profound. Sometimes the most alien-looking environments might be the friendliest to microscopic life. For a microbe adapted to extreme cold, constant radiation, and chemical feasts of sulfur or iron, a world like Enceladus could be paradise. Volcanoes on Earth, fire at the ends of the world. Back on Earth, volcanoes shape our history and our imagination. In Antarctica, Mount Erebus rises 3,800 meters above the Ross Sea, crowned with a rare, permanent lava lake. Here, molten rock bubbles endlessly, breathing in and out with volcanic gases. Around its slopes, vents release steam that instantly freezes, building bizarre ice towers, chimneys of crystal that hide vast cave systems below. Step inside and you find sparkling ice walls, tunnels lit by sunlight filtering through snow, and microbes that thrive in warmth created by volcanic gases. It is a living laboratory for how life might exist on Mars or Europa. Erebus is as dangerous as it is beautiful. Small eruptions regularly hurl lava bombs hundreds of meters into the air, and more than one scientist has narrowly escaped death while studying it. One researcher, struck unconscious during an eruption, later discovered a walnut-sized piece of his brain had been destroyed, yet he still returned, drawn by the volcano's allure for decades. For him, Erebus wasn't just a mountain. It was a lifelong companion, a fiery birthday candle glowing in Antarctica's frozen dark. On the other side of the globe lies Kawah Ijen in Indonesia, home to the world's largest hyperacidic lake. Its waters shimmer a surreal turquoise, but are as corrosive as battery acid. At night, streams of blue fire flicker across the landscape, created by burning sulfur gases. Miners descend daily into this toxic crater, chiseling yellow sulfur crystals amid choking fumes, often carrying 70 to 80 kilograms on their backs for just a few dollars a day. It is one of Earth's most hostile workplaces, a reminder of both human endurance and human cost. The restless Earth, Iceland's living fire. Iceland, straddling the mid-Atlantic ridge, is a land literally split apart by tectonic plates. It hosts more than 30 active volcanic systems, fueled not only by the rift between continents, but also by a deep mantle plume that supercharges eruptions. In 2021, the Fagradalsfjall volcano erupted for the first time in 6,000 years. Before the eruption, the ground shook with 50,000 earthquakes in just a few weeks as magma forced its way upward. When the fissures finally opened, glowing rivers of lava poured into valleys, reshaping the land in real time. People hiked to the eruption site to watch in awe, standing meters away from lava fountains that glowed against the Icelandic night. For scientists, it was a rare chance to study a newborn eruption. For locals, it was a reminder that Iceland's fire is never far below their feet. Why volcanoes matter? Volcanoes do more than terrify us with their power. They sustain life. On Earth, volcanic gases helped create our atmosphere. Lava enriches soils, making some of the most fertile farmland on the planet. Hydrothermal vents, fueled by volcanic heat under the oceans, host ecosystems that survive without sunlight, thriving on chemical energy alone. Many scientists believe life itself may have begun around such volcanic vents billions of years ago. And beyond Earth, volcanoes may still hold the key to answering humanity's greatest question: are we alone? If microbes can survive the acid lakes of Indonesia, the ice caves of Antarctica, or the boiling vents of the deep ocean, then surely they can survive in the plumes of Enceladus or the oceans of Europa. Volcanoes, whether fiery or icy, deliver the energy and chemistry life needs. They may already be nurturing alien ecosystems as we speak. The call of fire and ice. Every volcano has a personality. Some breathe softly for centuries. Others explode with no warning. They are destroyers of cities and makers of continents. They terrify us, inspire us, and, strangely, sustain us. To climb a crater rim, to feel the heat on your skin while snow falls around you, or to watch blue flames lick the night sky, is to understand something primal. Planets are alive. Their hearts beat in fire and ice. And in those rhythms, we might one day find the proof that life is not unique to Earth. Whether we discover alien microbes in icy plumes or not, volcanoes ensure that the cosmos will never be still. They are the eternal storytellers of worlds.